Good morning, children. Last time we had started with the chapter Amines, where we had done the introduction part and the nomenclature. Today we will be taking up the next topic, that is preparation of amines. Preparation of amines, there are different preparations of amines given here. One by one we will take up all the preparations. Among them, the first one is reduction of nitro compounds. Nitro compounds meaning where the compounds has the functional group NO2. That kind of compound is called as nitro compounds. Okay. Both aliphatic and aromatic amines can be prepared by the reduction of nitro compounds. Okay. Now when we say reduction of nitro compounds, again there are different methods. The first one is catalytic reduction. Catalytic reduction where we are using catalyst to reduce the nitro compound. Okay. So first we will see the catalytic reduction. Generally RNO2 is the aliphatic nitro compound. When you reduce it with hydrogen in presence of a catalyst like nickel and in ethanol, it will give you the corresponding amine, that is RNH2 plus 2H2O. So this is your reduction. What do you do? NO2 जो है, NO2 हटा के वहाँ पे NH2 रख दो. So that is how you will get the equation. Here AR indicates what? It is a benzene ring. Okay, aryl group है यहाँ पे. When ArNO2 is reduced with H2 in presence of PDC, that is palladium charcoal catalyst, in the presence of ethanol, it will give you AR. Replace the NO2 group by NH2 plus 2H2O. So you can take one example. This is what? This is nitroethane. Okay, the name of this compound is nitroethane. Reduce it with H2 in presence of platinum. Platinum is another metal which can be used as a catalyst. In the presence of ethanol, we will get CH3, CH2, NH2 plus 2H2. So that is how you get different reactions showing the catalytic reduction of the nitro compounds. Okay? Next is, we can even reduce it with active metals like Fe, Sn, Zn in presence of concentrated HCl. So if I take the general equation RNO2 plus Fe, HCl, it will give you RNH2. You get the corresponding amine. Okay? Or you take an example and see CH3, CH2, NO2, Sn, HCl will give you CH3, CH2 and H2. This is what ethanamine. This is nitroethane. So you can write down the name of the compounds. Nitroethane. Okay? And this is ethanamine. Ethanamine. So that way you can get the reduction process carried out with the help of an active metal in presence of concentrated HCl. अब यहाँ पे very important division question comes. Why FeHCl or iron scraps in presence of HCl is used or preferred over Sn and HCl? That is because वो इसलिए होता है क्योंकि when FeHCl reacts to give you FeCl2, and this FeCl2 on hydrolysis will give again the HCl. So with very little amount of HCl only you can carry out the reaction, because in the reaction process HCl is being produced, so it becomes cheaper. So therefore FeHCl is preferred over SnHCl. We can write the reason as because FeCl2 produced during the during the reaction, hydrolysis to give HCl. So with very little HCl, we can start the reaction, making it cheaper. ठीक है, क्योंकि HCl का कॉस्ट इज बीइंग एलिमिनेटेड, बिकॉज ड्यूरिंग द रिएक्शन जो भी FeCl2 बनता है उसका हाइड्रोलाइसिस होके it will give you the HCl. So in the reaction mixture only HCl is being continuously produced, so that we can start the reaction with very little amount of HCl. Okay, so makes the reaction cheap. Then the next is, two of them we have discussed. One is by catalytic reduction, other is by the action of active metals in presence of HCl. Now third reduction of nitro compound is with lithium aluminum hydride, LiAlH. ये तुम्हारा lithium aluminum hydride है. CH3CH2NO2, that is nitroethane, example we are taking. In presence of lithium aluminum hydride dry ether, it gets converted to CH3 CH2 NH2. So this is your ethane amine. ठीक है? So ethane amine is a primary amine, isn't it? So this will, the aliphatic nitro group will give you the ethane amine, that is the primary amine. ये है ना, this is C, this is your primary amine. ठीक है? But when you use nitrobenzene, है ना, C6H5NO2 क्या होता है? Actually the structure you show this C6H5NO2 means benzene ring NO2. So when you carry out the reduction with lithium aluminum hydride dry ether, don't expect that you will get benzene ring with NH2. जैसे we had seen here with the catalytic reduction. No, here the product which will be formed is this one. Can you see here? C6H5N double bond N benzene, C6H5, and this is called as azobenzene. What is this called as? Azobenzene. The N double bond N is called as the azobenzene. Okay, so this is your azobenzene being formed. So here we do not get primary amine. Okay, we do not get primary amine. ठीक है, प्राइमरी अमाइन नहीं मिलता हमें यहाँ पे, हमें जो मिलेगा वो है azobenzene. Usually we will be expecting nitro group to be reduced to NH2, but that does not happen. Okay, what is the name of this compound? It is nitrobenzene. Okay, so these are the different reactions where you find the nitro group is reduced to NH2, that is amine group, and you get the amine compounds, aliphatic amines and aromatic amines. Okay, so this is the first method for the preparation of amines. Okay, note down, then we will go to the second one. The second method is Hoffman's ammonolysis method, or we say it as ammonolysis of alkyl halides. You know alkyl halides matlab any compound which is having Cl as the Cl, F, Br, I, all the halogens as the functional group. They are known as halides. We had a chapter on haloalkanes, isn't it? So using alkyl halides, we can have the preparation of amines. Okay, वो किस तरह से? देखो, alcoholic ammonia which is alcoholic, which is prepared in alcohol, that is called as alcoholic ammonia, is treated with the alkyl halide first. Okay, treated with alkyl halide. Now alkyl halide is Rx, ठीक है. Rx ये जो bond है, X being more electronegative will shift the electron pair towards X negative charge, R is having partial positive charge. So this pair of electron which is present over nitrogen, it is moving towards R, and you have a ammonium salt being formed here. Primary ammonium salt being formed here. Okay. This primary ammonium salt, again in presence of ammonia, will convert into primary amine. Okay. So this is your primary amine, and this is the ammonium salt, depending on what is taken as your X. So I hope you understand the first equation. The ammonia, which is prepared in alcohol or alcoholic ammonia, reacts with alkyl halide. This is your alkyl halide. Okay? This alkyl halide, on reaction with alcoholic ammonium, first forms primary ammonium salt. This primary ammonium salt, in presence of it reacting with more ammonia, it will give you the primary amine along with the ammonium salt. Okay? Now, in the reaction mixture, okay, this primary amine will again undergo reaction with alkyl halide, and same way, okay, ये जो नाइट्रोजन के ऊपर जो नॉन बॉन्डिंग पेयर ऑफ इलेक्ट्रॉन है, that will go with R and X, forming, this is your secondary ammonium salt. This is your primary ammonium salt. Salt क्यों बोल रहे हैं? क्योंकि इसमें प्लस both are there, पॉजिटिव आयन है, नेगेटिव आयन. This is the salt. This is the secondary ammonium salt. Okay, secondary ammonium salt. Follow? Reaction with more amount of ammonia, it will give you R2NH, that is your secondary amine. Okay, and the ammonium salt. This secondary amine again undergoes reaction with alkyl halide to give you the tertiary ammonium salt first, and then the tertiary amine. Okay, along with the ammonium salt. So this is how the reaction goes one after the other. The tertiary amine will again undergo reaction with alkyl halide to give you the quaternary ammonium salt. This is the quaternary ammonium salt. ठीक है? क्योंकि R4N है. So this is your quaternary ammonium salt. This is your tertiary ammonium salt. Okay, so in this way the reaction mixture will have all these things, that is primary amine भी होगा, secondary amine, tertiary amine and quaternary ammonium salt. So since there is a mixture of primary, secondary, tertiary and quaternary ammonium salts or amines, this particular reaction, it is not used in laboratory, because in laboratory the method of separation of all these amines, है ना, तीनों type of amines are being formed, primary, secondary and tertiary. तो ये तीनों type of amines cannot be separated. उनका जो separation है, that is not an easy method. So in the laboratories it becomes difficult for us to separate out these amines. On industrial basis it can be done on large scale. So in industries the separation becomes simple, but in the laboratory this particular separation of these different kind of amines is difficult. So therefore in laboratory this method is not being used. It is not giving one kind of amine. We don't want mixture of amines, isn't it? We want a particular amine. So therefore this method cannot be used to obtain a single kind of amine. Okay, we get a mixture of amines. So that is one of the limitations. Okay, ये जो reaction है, this reaction we get a mixture of amines. Therefore this is not used for getting a particular amine, a primary amine or a secondary amine or a tertiary amine. Another limitation is that only aliphatic amines can be prepared by this method. Aromatic amines cannot be prepared. जैसे aniline नहीं बन सकता इधर इस मेथड से, वो इसीलिए क्योंकि the alkyl when we say alkyl halide, when we want aniline as the product, then we should be using aryl halide. Aryl halide जैसे chlorobenzene use करना पड़ेगा. तो chlorobenzene is very reluctant or very, it does not react with ammonia to give a nucleophilic substitution reaction. You can see here that there is a nucleophilic substitution reaction is being occurring here. See X जो है वो replace हो जाता है with NH2. So all these reactions what we have just discussed now, they are all nucleophilic substitution reaction. लेकिन aryl halides में they do not undergo nucleophilic substitution reaction. They are very less. These aryl halides are very less reactive towards the substitution reactions. Therefore, we cannot prepare primary aryl amine from this method. Okay, so that you can write as a limitation. एक limitation तो ये है कि we get a mixture of amines, mixture of aliphatic amines, which is difficult to separate. So therefore, this method is not very useful. Okay. Second limitation is that primary aryl amines cannot be prepared. Primary aryl amines cannot be prepared by this method. Cannot be prepared by this method because aryl amines do not undergo nucleophilic substitution. ये हमने जब एलोएल्केन्स पढ़ा था तभी भी हमने देखा था कि nucleophilic substitution reactions are not possible with the aryl halides या haloarenes हमने पढ़ा था जैसे, क्योंकि very difficult to undergo nucleophilic substitution reaction. So it undergoes nucleophilic substitution only under drastic conditions. So we have seen there also that these aryl halides, yeah, haloarenes, they are not undergoing nucleophilic substitution reactions. Okay, so that is a limitation of this method. That is Hoffman's analysis method. Okay, aliphatic amines can be prepared because these alkyl halides and the aliphatic alkyl halides undergo nucleophilic substitution reaction. So that is regarding Hoffman's analysis method. Now third method is from the nitriles and isonitriles. When I say nitriles and isonitriles are NCB, okay, and nitriles are CN. So we can prepare both nitriles or isonitriles use करके we can prepare the amines. Nitriles will give you primary amine and isonitriles will give you secondary amine, क्योंकि वहाँ पे NC है, N triple bond C is the functional group. So there you will find that nitrogen is being bonded to two other carbon atoms. Okay, so when you write the equation, that time you can understand. ठीक है, जैसे ये हो गया RCN. This is the nitrile. Okay, this is the nitrile. Alkyl nitrile. This is aryl nitrile. In presence of ranitol H2, it will give you RCH2 NH2. ऐसा होगा. So you are adding up hydrogens at C and N, giving RCH2 NH2. This is a primary amine. Okay. Similarly, aryl amines कैसे बनते हैं? RCH2 NH. ठीक है, RCH2 NH2. अगर हम एक एग्जाम्पल लेके देखें तो CH3 CH2 C triple bond X. ये कौन सा नाम होगा इसका? What will be the name? There are three carbons, so it is propane nitrile. ठीक है, propane nitrile. In presence of ranane nickel H2, it gives you what? CH3, CH2, CH2, NH2. तो यहाँ पे what do you see? What do you observe? That we are getting a amine addition of H2 is taking place at C and at N. ठीक है? तो ये हो जाएगा तुम्हारा प्रोपेन अमाइन. ओके? प्रोपेन अमाइन. I hope it is clear. Okay? राइट वाला भी देख लेते हैं. बेंजीन रिंग CN ले लेते हैं. ठीक है? Cyanobenzene or benzene nitride basic in presence of Li, Al, H4, ether. It gives you what? Benzene ring, CH2, NH. Okay, so this is benzyl amine. What is the name? Benzyl amine. Followed? So benzyl amine you will get here, and we have started here with propane nitride, so you will get here as propane amine. ठीक है? So this is a very important reaction. Reason ये है कि we can get an alkyl. When we start with alkyl halide, we can get a amine which is having one carbon more. Whenever we want an alkyl halide से amine बनाना है, then we get an amine which we require having one carbon more. So that is why it is a very important reaction. देखो, alkyl halides, no? This is the reaction I will show you. This is alkyl halide. Alkyl halide easily undergoes substitution with Cn, and X is replaced with or substituted by Cn, and this reaction is very easy. Alcoholic KCN use करो or NaCN, anyone you can use. So what do you get? RCN. Okay, so you have got the nitrite compound from the alkyl halide. ठीक है? Alkyl halide में there was how many carbon attached to? If R you take as CH3X ले लेते हैं तो 1 carbon होगा. Okay, but when you go to the nitrile group you have CH3C. अगर आप हम लोग CH3 consider करें तो ठीक है, so you get 1 carbon more, and reduction with H2 Ni, it gives you what? R CH2 NH2. So here you have obtained an amine which is 1 carbon more than what you started with the alkyl halide. So you can convert alkyl halides into amines with 1 carbon more very easily by this method. Okay, so it has a very practical use उसका बहुत high है. Let me take one example and show you. CH3CH2Cl. This is ethyl chloride या chloroethane. Easily undergoes substitution reaction with alcoholic KCN, giving you CH3 CH2 CN. ये कौन सा कंपाउंड है? प्रोपेन नाइट्राइड हो गया. So you started with ethyl chloride या chloroethane. You got your propane nitride, 1 carbon more. And when you reduce this with H2 Ni, what do you get? You get CH3 CH2 CH2 and H2. So you started with ethyl chloride and you get the product amine with 1 carbon more. Okay? So this is chloroethane and this is propane amine. Okay? Propane amine. So are you understanding the importance? So whenever during conversion, when you get in the examinations, you want 1 carbon more amine starting with alkyl halide, you can use this method. Okay, so synthetic importance is very high because conversion of alkyl halide to a primary amine with 1 carbon more is very easily possible by these reactions. So this is how you can obtain amines by reduction of nitriles या फिर cyanines. ठीक है, copied out this, then I can go to isonitrite. The second method is reduction of isocyanides or carbyl amines. The previous reaction I just did not mention. Those reactions are called as Mendes reaction, MENDIUS. So please note down that the previous reactions, it is also called as the Mendes reaction. Okay. Now next is reduction of isocyanides or carbyl amines. Isocyanides we represent by, this is the alkyl isocyanide, that is RN triple bond C. Okay. With H2Ni. Any catalytic reduction is taking place to give you N-methyl alkyl amine. N-methyl alkyl amine. Okay. So we'll give one equation. Say for example CH3 CH2 and triple bond C in presence of H2 Ni gives you what? You see RCH2 and triple bond C will get converted to RCH2 and HCH. ठीक है, अगर हम लोग एक एराइल कंपाउंड ले लेते हैं जैसे बेंजीन रिंग विद N triple bond C, then in presence of H2 Ni, then what you will get? Benzene ring, okay, and HCH, okay, this will be N-methyl benzamide. ठीक है, so this is the phenyl isocyanide and this is ethyl isocyanide. I write the names here. This is ethyl isocyanide, okay, and this is phenyl, it is phenyl isocyanide, okay, and what do you get? N-methyl benzamide, okay, or N-methyl aniline also you can say. So this is N-methyl aniline, and this is, since we have taken here R नहीं रखा है, CH3 CH2 रखा है, so this is N-methyl ethanamine. Okay, what is the name of this compound? This is N-methyl ethanamine. I hope it is clear. Okay, so these are the reactions where you can show the reduction of isocyanides or carbyl amines. Now, what is the limitation of this equation or this reaction is that in this method you can only prepare secondary amine. That also one of the alkyl group will always be a methyl group. You cannot have any other alkyl group on one side of the nitrogen. You will always have it as methyl group. So if you require any other group here, then this method is not useful to us. So therefore, this is the limitation. This method can only be used to prepare. So this is the limitation. Okay. So if these all things, no, it can come as conceptual questions, and say in assertion, reason type of a question. These all things can be you asked as the question. It can be, what is the limitation of this carbylamine, reduction of carbylamine? It is that this method can only be prepared to used for preparation of secondary amine, in which one of the alkyl group always will be a methyl group. Okay. Then the third is hydrolysis of isocyanides or carbylamines. Hydrolysis, these alkyl isocyanides जो बनते हैं, ठीक है, this undergoes hydrolysis only in presence of acids. Okay, ये एक बात याद रखना. We cannot have this hydrolysis occurring with an alkali. Okay, this only takes place in presence of an acid, and you will get the corresponding amine. Okay, so you get the corresponding amine along with the acid. what is the thing you understand? What do you notice here? कि we started with R N C. Okay. Now we have what? R N H2. So one carbon is becoming less here. So that should be noted here कि ये जो reaction है it gives primary amines with one carbon less. Okay. This reaction gives primary amine with one carbon less. ये बात भी important है, it's quite important here. Okay, so that is the importance of hydrolysis of isocyanates. Remember that this hydrolysis of isocyanates take place only in presence of acids and not alkalis. Okay. Then reduction of amides. Amide मतलब functional group CONH2 होना चाहिए. So CONH2 in presence of reducing agent like LiAlH4 in presence of ether and then carrying out the hydrolysis, it gives you the corresponding amine, primary amine देगा. ठीक है? तो एक example ले लेते हैं. What is this? CH3CONH2. What is the name of this compound? इसका common name है acetamide. Or we can say ethanamide. ठीक है? IUPAC system में this will be called as ethanamide. AMIDE. So when you carry out the reduction and then hydrolysis, you will get the corresponding amine. Okay? CH3, CH2, NH2. Okay? You add here H2. Followed? So that is how we have benzamide ले लेते हैं. Benzamide is what? Benzene ring, CO, NH2. ठीक है? LiAlH4 and water. It gives you what? Benzene ring, CH2 and H2. This is which amine? This is benzyl amine. Okay? So you get here benzyl amine. You started with benzamide. तो यहाँ पे you can see that all of them it is primary amine. ठीक है? Secondary amine भी मिल सकता है reduction of amides के साथ. So for that you have to take, see, this is N-methyl ethanamide. Okay? This is N-dimethyl ethanamide. Okay? So what is the name of this compound? This is N-methyl ethanamide or acetamide. That also you can write. Okay? N-methyl acetamide. And write it as acetamide. Okay? N-methyl acetamide. This is N-dimethyl acetamide. Okay? Both of them you will get secondary CH3. यहाँ पे tertiary मिल जाएगा. यहाँ पे you will get what? CH3, CH2, NH, CH3, CH3, CH. So here you have a tertiary amine. Okay, so this is secondary amine, N-methyl ethanamide और यहाँ पे N-dimethyl ethanamide. ठीक है? So this is your tertiary amine. So you get different kind of amines, primary, secondary and tertiary amines by using the reduction of amines. ठीक है? So this is the various informations regarding preparation of amines by cyanides and isocyanides. Cyanides का reduction to amine, it is also called as Mendel's reaction. Okay? So note down this, then we can go to the next method for preparation. The next set of reaction is for the preparation of amines is Gabriel thalamide reaction. अब ये reaction में you are taking thalamide, okay? This compound benzene CO NH with another CO group attached is called as thalamide, okay? Taking alcoholic KOH, you first get potassium thalamide, okay? KOH, you form the salt here. This is base, this is the base, this will be the derivative which you are obtained from an acid. So here you will get first the potassium, okay? This is called as potassium thalamide, PHTHALIMID. Potassium thalamide salt you will get. This potassium thalamide salt, you treat it with an alkyl halide, okay? Heat it. So what do we get? We get N-ethyl thalamide. Okay, what is this? This is N-ethyl because we have taken ethyl here. If you had taken some other alkyl chain, then you would have got methyl here hota to N-methyl. Okay, so N-ethyl thalamide. Okay, now N-ethyl thalamide or hydrolysis will give you what? The phthalic acid and ethylamine. Okay, this is phthalic acid. Benzene ring CWH at 1 and 2 positions is called as phthalic acid. This phthalic acid and you will get the ethanamide, the primary amine you are obtaining here. Okay, so this is your primary amine. अब ये जो phthalic acid है, again you can convert into thalamide and again you can carry out this process. So this can be reused here. Okay, so this is how you obtain a primary amine, a aliphatic primary amine using thalamide with some alkyl halide. Okay? Now what is the limitation of this? Can you get, here you have got aliphatic amine, can you get the aryl amine here? We cannot get. The reason is, when we use an aryl halide here, this aryl halide will not undergo nucleophilic substitution reaction. So therefore, you won't get the aryl amine. Okay, that's the limitation. Okay, aromatic primary amines cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution reaction. They do not undergo nucleophilic substitution reaction. That is the reason why we cannot find aromatic primary amine being obtained by this method. Okay? So that is, this reaction is very important from examination point of view. Okay? So you can write here important. As a 2 mark question it can be asked. Write the preparation, write the Gabriel thalamide reaction. Otherwise also, name reactions all you should be very thorough. See, you have learned such a lot of reactions in your previous chapters, that is starting from haloalkanes, then coming to alcohols, then coming to carboxylic acids, ethers, so many different compounds with so many different reactions you have learned. So all those reactions, if you keep on practicing, then only you will be thorough with. Now today also we have learned so many reactions. All these reactions as such it won't be asked. They might be asked in the form of a conversion, where you have to mix up all these reactions. So unless you are thorough with these reactions, you will be not able to do the conversions. Okay? So very important that you keep on practicing the reactions, even the previous chapter reactions. Be very thorough with all the reactions, then only you will be able to carry out the conversions. Okay? So that was thalamide, Gabriel thalamide reaction. Now coming to Hoffman degradation of primary amine या Hoffman bromide reaction, इसको ये भी कहते हैं, and this is also a very important reaction from examination point of view because many a times it has been asked. So what are you starting with? It is an amide. Okay, so this is an alkyl amide. Okay, you treat it with Br2 and KOH. You get the primary amine. This is your primary amine with, what do you notice here? We get with 1 carbon less. ठीक है? जैसे हमने लिया acetamide, CH3CO NH2. This is acetamide. Okay? What is this? This is acetamide. You treat it with Br2 with KOH. What do you observe? We observe that you get CH3 NH2. So one carbon is less. So you get CH3NH2 plus all these byproducts you will get, that is K2Cr, K2CO3 plus 2KBr plus 2 H2O. Okay, similarly if you take benzamide, benzamide is having what structure? This is benzene ring, CO, NH2. So this is benzamide. Benzamide. Again with Br2KOH. Don't forget to put the stoichiometric coefficient also. Okay, that is also very important here. It will give you NH. Okay, so this is your aniline. So that is how you obtain various reactions, which is coming under Hofmann degradation of primary amine. Then you have Schmidt reaction, where you find carboxylic acid reacting with N3H. N3H is what? It is hydrozoic acid. What is it? It is hydrozoic acid to give you the primary amine along with the release of CO2 and N2. Okay, so this is also another important reaction. It might not be there. There are few reactions which might not be there in the textbook, but all those you have to revise, you have to learn it because it is useful for your competitive exams. Okay, so here this is acetic acid, this is benzoic acid. Acetic acid हाइड्रोसोइक एसिड के साथ रिएक्ट करके यू गेट द प्राइमरी अमाइन। बेंजोइक एसिड है ये, बेंजोइक एसिड रिएक्ट्स विद हाइड्रोसोइक एसिड टू गिव यू बेंजमाइन। ठीक है, सो दिस इज बेंजोइक एसिड, ओके, and this is benzamide. Okay, so these are how the different ways of preparation of amines is discussed in your book. There are exercises in text questions given where solution is also given, and there are questions which do not have solutions. They are all reactions. So all those you have to, as we have completed this topic, go to the textbook, take out all the reactions related to this and try to solve it. Okay, and be thorough with all the reactions. For today we have learned this reaction, so then you should be very thorough with all these reactions. We have learned 7 reactions in all. So all these 7 reactions with their limitations, all you have to learn it properly. Okay, so